Hi, welcome to this video on confidence intervals. This video will talk about what is a confidence intervals and the basics of constructing them. In the later videos, we'll go into different types of confidence intervals. So let's start off first with an example of the admissions director at a university proposes using the IQ scores of current students as a marketing tool to show how smart their students are, and the university provides the admissions director with just enough money to do only 50 students of the 5,000 freshman class. So the admissions director takes a simple random sample of those 50 students, and he gets a mean of 112. Now, is that the mean of all 5,000 freshmen? Probably not. It could be, but there's a fair likelihood that it's not. So we're going to use the central limit theorem to help us figure out what would be the range of values. Given this sample, what's a good range of values to say the population mean falls within? So to review the central limit theorem, that says if I take all possible 50 samples of that 5,000 freshman class, the mean of all of those samples would be the same as the mean of the population. And the standard deviation would be the population standard deviation divided by the square root of the sample size, plus or minus. And it would be approximately normal. So we're going to use this information to give ourselves a range where the population could fall within. All right. We're going to start off first, though, using the 68, 95, 99.7 empirical rule to help you get a little more comfortable with how we're calculating the range of the confidence interval. So if we do 95%, that is plus or minus 2 standard deviations. One is 68. So we're going to do plus or minus 2 standard deviations from the mean to be 95% confident that the population mean is going to fall within this range we're going to calculate. All right, so one thing we have to assume, which is very unlikely, is that we know sigma, the population standard deviation. Now, this is very unlikely for a multitude of reasons, but the main one is if you know the population standard deviation, you're going to know the mean because you have to use that to calculate the standard deviation. So if you know the population mean, this whole thing is pointless because you know what it is. But again, we have to start to walk before we run. So let's first figure out what the sample standard deviation is. So the sample standard deviation, we're assuming the population is 15, so the sample is 15 divided by rad 50, our sample size, and we get 2.1 is our sampling distribution standard deviation. So for 95% of the samples to be 95% of those samples to be within 2 standard deviations will be within 2 standard deviations of the mean. So here is a picture. We have our mean. We're minus 2 times 2.1 and plus 2 times 2.1. So we have one sample, and that was 112, and we could add and subtract 4.2 to get a range for that confidence interval. We could have taken another sample of 50 people. Say we got 109. That would give us a different confidence interval. And we could also do a third sample, get 114. That'd give us another confidence interval. And you could take a bunch of samples. A lot of them will come out different, but they'll all be close to each other, and a lot of them will overlap. So confidence in statistics is different than confidence in real life. So it's how confident are you that you captured the population mean within your interval? That's what the confidence is going to tell us. So let's finish up our interval, and then we'll go with the specific interpretation of confidence. So we got 112 plus or minus 4.2, and that gives us this interval here. And how we would interpret this is that we would say we are 95% confident that the interval 107.8 to 116.2 contains the true population mean of the IQ for all big city university freshmen. So this is saying we're 95% confident that the population is somewhere between those two numbers because of central limit theorem and the normal curve. Here is the fill in the blank that I would pause the video and kind of write down until you're really confident on you know what confidence means. Until you yourself are 95% confident you know what 95% confident means. It's good to have like a framework that you would plug in. You would say how confident you are that the population mean of in context. So this would be in context here, whatever you're measuring. And then between the 2 points for your beginning and end of your confidence interval. All right, so let me show you what confidence intervals actually mean with this applet here. So here we have something that will make a bunch of confidence intervals. So we're going to go to means. Z with sigma, we're doing a Z interval because that's only used when you know the population standard deviation. So that's what we are doing right now. And then you could change what the population is. It's not going to matter since our sample size is 50. Our sigma was 15. That's the population sigma, not the sampling distribution sigma. This will do that calculation in the background. And our mean was 112. Right. So now this mean here, notice it's next to mu, where I'm just going to pretend that 112 was in fact the population mean. It's not going to be an issue for what this illustrates. And let's start off just with 10 intervals. All right, sample. So this calculated 10 samples and then created confidence intervals for those 10 samples. Out of these 10 samples, if 112 were the real population mean, 8 of them caught that mean, and 2 of them were slightly off and didn't actually catch the population mean. So then if I sample again, all 10 of the next one caught the population mean. So right now we're up at 95%. And if I do it again, all the next 10 did, next 10 did. Here, 1 did not. So we're up right around 94%. If we reset this and let's do 100 samples at a time, 100 intervals at a time here. Here we got 96 out of the 100 caught the population mean, 4 did not. Let's do one more. So here, let's see, 92 caught the population mean, but 8 of them did not. So our running total is 94% of our intervals caught the population mean. And this is what confidence means. So the confidence is essentially doing all the statistics correct. We're confident that 95 out of 100 times, if we repeat these process, we'll create an interval that captures the true population mean. Sometimes we can do everything right, and these red ones are those times when we did everything right, but we still didn't capture the population mean just because of how the sample turned out. And most publications in scientific journals want 95% confidence to publish things, and if you looked at a lot of the 538 things they post on their site, it's 95% confidence. Sometimes it's a little different based on the sample size. That can affect it later on, your confidence level. But notice that each individual confidence interval either does or does not capture the true population mean. So it's not the probability that one particular interval captured the population mean, because one interval either did or did not. There's no in between. We just don't know what it is. But 95 out of 100 times we will create an interval that does capture the mean. And if we go back, that is the end of this video. So the next videos will go into the math of actually creating a z-interval.